Hi all, welcome to SRK Template class. We will discuss the transformer EMF equation. Discuss transformer bindings primary winding and secondary winding. Primary winding we supply alternating flux develop. So if you are drawing the shape of the alternating flux, alternating flux is sinusoidal flux. So it will be the shape will be this 0, pi, 2 pi, omega t. So the maximum flux that will be developed will be equal to phi m. Okay. So 5 is omega t. Input voltage apply primary winding apply voltage apply alternating flux. So our flux in represent phi is equal to phi m sin omega t and represent phi is equal to phi m sin omega t and represent. So Faraday's law according to Faraday's law, transformer working principle is Faraday's law of electromagnetic induction. So according to Faraday's law, induced EMF will be equal to d phi by dt. E is proportional to d phi by dt, or we can write E is equal to n into d phi by dt. E is equal to n into d phi by dt. Now, induced EMF. Induced EMF always it opposes the applied voltage. So, Lenz's law. So, according to Lenz's law, induced EMF is equal to minus n into d phi by dt. This is the representation of a Lenz's law. E is equal to minus n into d phi by dt. So, we can write E is equal to minus n into d by dt of, we know that phi is phi m sin omega t. So, phi m sin omega t. This will becomes minus n into phi m is a constant, so phi m number common. So that is d by dt of sin omega t. So sin omega t differential. So n phi m sin omega t differential. This is not cos omega t. So n cos phi m cos omega t into omega. So minus n omega phi m cos omega t represent. This is nothing but our E. Suppose our primary, if primary has n1 turns, n1 number of turns, n1 turns, and secondary has n2 turns. Secondary has n2 turns. So represent E1 is equal to minus n1 omega phi m cos omega t and represent. Right? Now my aim is to change this minus omega t. So I am replacing this as minus cos theta sin of theta minus 90 degree. Okay, minus cos theta sin theta minus 90 degree. So theta is cos omega t. So this will becomes n1 omega phi m sin of omega t minus 90 degree, or it is pi by 2, minus pi by 2. Okay, n1 omega phi m sin omega t minus pi by 2. So we can write this E1 is equal to n1 omega 2 pi f phi m sin of omega t minus pi by 2. Let this equation number 1. Now I am going to compare this equation with our standard equation. Compare with the standard equation. What is the standard equation? Is E is equal to Em sin omega t. This is my sin omega t plus theta. This is my standard relation. E is equal to Em sin omega t plus theta. So when we are comparing this equation, this is my second equation. So comparing 1 and 2. We are comparing equation number 1 and 2 It is clear. The maximum value will be equal to 2 pi f n1 into phi m, and the value of theta is equal to minus pi by 2. It's clear. So maximum value is 2 pi f n1 phi m and theta is minus pi by 2. So if I am talking about the RMS value of induced EMF, if we are talking about the RMS value of induced EMF, RMS value of induced EMF നമുക്ക് അറിയാലേ, maximum value divided by root 2, that is EM by root 2 is the RMS value of induced EMF. So that means this can be written as 2 pi f n1 phi m divided by root 2. So this 2 pi by root 2, this 2 pi by root 2 is nothing but our 4.44. So this becomes 4.44 f phi m n1. This is the standard relation of equation. Okay, so this means we can write E1 is equal to 4.44 f phi m n1. This is the EMF equation of a transformer. If it is E1 is equal to 4.44 f phi m n1, then we can write this E2 is equal to 4.44 f phi m n2. So we can derive the same thing for the secondary thing also. Only thing, if there are n2 number of turns, this will become n2. So this is what our EMF equation of a transformer. Clear? Now again, if the value of theta is minus pi by 2, so theta is equal to pi by 2 minus pi by 2, but it means theta is equal to minus pi by 2 means it lags the, means the theta will lag or flux will lags. Okay, our phi lags our E1 and E2 by an angle 90 degree by pi by 2. That means if I am taking the reference as the flux phi, E1, both E1 and E2 lag by 90 degree. So this is my E1 and this is my E2. So this is what we get from this equation. E1 is equal to n1 2 pi f phi m sin omega t minus pi by 2. From that it's clear that our induced EMF in the primary and secondary winding is lagging the main flux by an angle 90 degree. So this is how we can derive the EMF equation of a transformer. E1 will be equal to 4.44 f phi m n1. E2 is equal to 4.44 f phi m n2. This is the equation of transformer. I hope you have an idea. You got an idea how to derive the EMF equation of a transformer. അപ്പോൾ ഈ വീഡിയോ നിങ്ങൾക്ക് യൂസ്ഫുൾ ആയിരുന്നുവെങ്കിൽ ലൈക്ക് ചെയ്യുക, ഷെയർ ചെയ്യുക, കമൻറ്റ് ചെയ്യുക, നിങ്ങളുടെ ഫ്രണ്ട്സിനോട് ഷെയർ ചെയ്യുക. ഓക്കെ, താങ്ക് യു.